All right, so here we are in applied regression, and I'm going to show a little bit of R code and an interpretation of the parameter estimates. So a previous video went over how to find the parameter estimates, but I'm going to actually open the R code to do that here. So the learning objective here is that you're going to be able to interpret the parameter estimates for the regression coefficients from the R output. So instead of just seeing what they are, you're going to be able to give an interpretation. So I'm going to use the cost of healthcare data. These data were shown in a previous video. So you have the variable names here, rural, bed, MC days, T days. The regression is going to involve net rev or net revenue as the dependent variable, and then bed, MC days, and T days as the explanatory variables. We're going to get this output here, but let's go ahead and go to the R code that generates this output. Okay, so I have the R code open here, and I'm going to use the read table function again, but you have the code, so I'm just going to go ahead and run it and do this out. So I get a summary of the different variables. So for example, bed here, minimum is 25 beds, maximum is 244, the median is 88, the mean is a little over 93. So just give some idea, right? Net revenue, minimum is negative, so hospital lost money. Maximum is 3219. This is in hundreds of dollars, so we need to multiply by 100 to get the dollar amount. Then before running the regression, it's typically a good idea to look at the variables, see how they're distributed, just check in case there are any problems. Let's go ahead and just do that here quickly. Not going to be a major issue. We can just look at the histogram for beds, right? So in this under 50 range, we saw that the minimum was 25. So we know there are some small facilities, but in that under 50 range, we can see that there are, looks like less than 5, right? Fewer than 5, so maybe 4. We can see that there aren't very many of these larger, more than 200 bed hospitals or facilities, right? So we can get simply an idea. Same thing for the days. MC days is the inpatient days. T days is total days. And then the revenue over here. You can just get a little picture and idea about those things as we look them through. Let's go ahead and run the regression. You've seen this before, but this is what provides us the output. So this just stored it into this object. If we actually want to see some of this, we would need to either tell it M01 and have it show that to us, or summary. And that's what I'm going to do here. So with this, it gives us the parameter estimates. Nothing new there. You've already seen this in a previous video. But what I want to do then is interpret, what does this negative 4,027 mean? And what does the 15.673 mean? And so on. What do these indicate? Well, these indicate the marginal impact, right? For bed, MC days, and T days. For the intercept, that tells us if bed were 0, and MC days were 0, and T days were 0, which is, in this example, silly, means we don't have a healthcare facility, right? So it'd be a little bit silly, but it tells us that the revenue would be negative, right? Negative 4,027, of course, that's in hundreds of dollars, but a little difficult to interpret there because none of these, if these things were all 0, this wouldn't be very meaningful. But what it does tell us, though, is that for every increase in bed, right, if this goes up by 1, then our expected outcome, the net revenue, would go up by 15.673, and again, that's in $100. So I'll get more to that in just a moment with the lecture notes. But just note on one other thing that you can do here. I'm going to produce an ANOVA table. So this ANOVA command, ANOVA for the model, will give us some additional output that we'll take a better look at later. Here it just tells us the sums of squares associated with these different variables. That's the sum of squares for the explanation for the dependent variable, the net revenue. We also have the sum of squared residuals. We'll take a little bit more. We'll take more time to look at the ANOVA table later, but we've got that going on there. All right, so again, we have the estimated model. I've abbreviated some of the things. So these coefficients, I've rounded them just to get them to fit here a little better. So we've got that. But again, what are these? These are the beta hats, right? So this is beta hat naught. This would be beta hat 1, beta hat 2, and beta hat 3. Well, what do they tell us? They tell us the impact of a marginal change, so just a 1 unit change, if you will, in their corresponding variable. So if bed changes by 1, then net revenue over here on the left-hand side is going to change by 15.7, and that's in hundreds of dollars. So that corresponds to $1,570, but I've written there 67 instead of 70, so $67 instead of 70, because just being a little more precise. If you go back and look at the actual output, it was 15.67. Right, so that's how you read that. So then the next couple of variables for MC days and T days, for looking at their coefficients, the beta hats out in front there on those ones, we're going to interpret them in the same fashion. So every additional 100 medical inpatient days, which is MC days, right? So if medical inpatient days goes up by 100, that means MC days goes up by 1, then expected net revenue is going to go up by $445. Again, being a little more precise than is written on this screen, right? So the 4.4 was actually 4.445, I think. And then same thing if we're looking at the total patient days. So if we had an additional 100 total patient days, that means that the variable T days goes up by 1, and the expected net revenue increases by $3,319. That looks like $3,320, but again, being more precise, and the actual regression output is 3,319. And so that's how you interpret, or the meaning of, those coefficients.